Hi, I'm Catherine, a Year 4 chemistry undergraduate student here at HKUST. My final year project was supervised by Professor Sun, and I worked on the development of a new organocatalytic method. This is the lab that I worked in. We'll have a quick tour around the lab and have a look at the daily life of an organic chemist. Organic chemists need to set up many reactions, and most of them are carried inside a fume hood that's equipped with good ventilation. This is the Schlenk line. It has two lines. One is linked to a vacuum pump, and the other is linked to nitrogen. Many of the reactions we work with are air sensitive. We use the Schlenk line to create a nitrogen atmosphere inside the reaction flask. This is the solvent purification system. We can have quick access to a series of different dry and water-free solvents using an SPS. Let me show you how to get solvents from the system. First, evacuate the system, create a vacuum inside, refill it with nitrogen, repeat this cycle 3 times. Switch to dispense and get your solvent. Take the amount you want, refill it with nitrogen, and then disconnect it. To learn about the progress of a chemical reaction, we frequently do TLC to monitor the reaction. We do thin layer chromatography using these glass plates that are covered with silica gel. Column chromatography is one of the most common methods used to purify a product. We pack the column, load the sample, and select an eluent system. We can either run it manually using this glass column or use the autocolumn machine to run it. The separation is based on the different polarities of the components inside a mixture. High-performance liquid chromatography is another common technique used for separation. These are a series of chiral columns. We can resolve the enantiomer selectivity of chiral compounds using HPLC. Now we have come to an end of this quick tour. Want to learn more about the infinite possibilities here on campus? I wish to see you in the future.
Hi, I'm Gordon, a Year 3 chemistry undergraduate student at HKUST. My research project was supervised by Professor Lin, and I work on the reaction mechanism of inorganic catalytic reactions. Let's see how we, the computational chemists, approach our projects. First, we calculate the energies of similar complexes. They are almost the same except that I change one specific ligand in the complex. After obtaining a wide range of energies, we try to propose a hypothesis to explain the relationship between the energies of complexes and the pi-accepting and sigma-donating nature of ligands using molecular orbital theories. To verify the hypothesis, we use PIO analysis, which is a technique developed by my supervisor's team to see the orbital interactions between the two fragments. We set up an input file which contains information like the coordinates of each atom, functional basis sets, which are different for different types of molecules. Then, we send the file to the computer cluster. Its efficiency is very high. It only takes a few hours or a day to finish the calculation of one complicated molecule. For molecule visualization, there are multiple softwares that serve the same function, but I personally use Gaussian and IQMol. In these softwares, you can see the conformation of the optimized structure from the output file. You can also see the vibrational frequencies and how they vibrate at a particular frequency, which helps validate your structure.